Hello everyone, today we're going to be looking at exponential growth and decay. Exponential growth and decay. Our functions are going to look like this right here, where we have function of x would equal a times the b to the power of x, also written as y equals a times the b to the power of x, where a is our initial value. Initial value. That's what we start with. Where's our starting point? B is our growth factor. That's what we're going to be multiplying by over and over and over. Our growth factor. And then x represents how long something is going to be growing, or how many. How long or how many. Now, our growth is going to look something like this over in the bottom left. With these, our a is going to be greater than 0, and b is going to be greater than 1, meaning it's getting bigger and bigger and bigger every time you multiply. And with the decay, a is still greater than 0, and b is going to be between 0 and 1. Some type of fraction or decimal, causing us to get some type of decay. Things are going to get smaller. So our initial value, that's our y-intercept. Where we cross the y-axis, and that's what we start with. Okay, so our y-intercept represents what are you starting with. So what you start with. B is our growth or decay factor. So B, that's going to be what we multiply by each time. Each time we do something, that's what we multiply it by. And then we have to figure out, what is our growth rate? How much are we actually growing each time? To find that, I'm going to take the absolute value of 1 minus b. So that's how much greater or less than 1 that b is. So how much is it actually growing? Our rate of growth. So looking at an example here, we're going to graph the following. We're going to identify some features for it. So my a in this case is 1. My b is 3. So if I make a table here, I'm going to have 0, 1, 2. Then we're going to put a couple of negative numbers here, -1 and -2, to go through and calculate these. I would take and have over here to the side y is equal to 1 times 3 to the power of 0. Remember, any number to the power of 0 is just 1. So that's going to be 1 times 1, or 1. Then I'm going to do it again, this time substituting for my x value the number 1. So that'd be 1 times 3, which is 3. And again, y equals 1 times 3 to the power of 2. So 1 times 9, because 3 times 3 is 9. That gives me 9. Now, whenever I remember, you got to remember the rules of negative exponents. This really means to do 1 times 1 over 3 to the power of 1, which is going to be 1/3. And then the last one, 1 times 3 to the power of -2. That would be 1 times 1 over 3 to the second power, which would be 1/9. And you could continue and make your table larger if you needed to. Now notice when we go to graph this, if I have 0, 1, I'll make my point a little bit larger here so we can see it a little better. So 0, 1. Then I have 1, go up 3 places. 2, I'm going to go up here to 9. At -1, I was at 1/3. Then 1/9. So my graph looks like this right here. It's coming down here. And it's going to approach the x-axis, but it will not touch the x-axis. That is what we call an asymptote here. Asymptotes. And we should remember those from some of our earlier things, but if we don't, we should know then that the asymptote, that is a line such that a curve approaches but never touches. So it's going to get closer and closer to the x-axis, but never touches. But never touches. In this case, our asymptote is going to be the x-axis, so it'll be the line y equals 0. So filling in the rest of these things here, our initial value for this one is 1, because that is my A value. My growth factor, which is my B, is going to be 3. And then to find my growth or decay rate, I'm going to take the absolute value of 1 minus 3. 1 minus 3 would be the absolute value of -2, or 2. So my growth rate, because this would be growth, it's getting bigger and bigger every time as it keeps going up, is 2. Now my domain has no restrictions on it. Therefore, we can say that it is all real numbers, and we can use our little symbol that looks like this, or you could write it as negative infinity to positive infinity. My range does have a restriction, because remember we have our asymptote. It's going to approach the asymptote, and as it approaches the asymptote, it's going to look like this right here. So it would say at 0 going to infinity. Or we could write it as y is greater than, not greater than equal, just greater than 0. An example of exponential growth. Looking at another example that we have right here. In this example, notice my A is 2, because that's my starting point. That's how much stuff I started with. B in this case is 1/2. So B is between 0 and 1. Since it's between 0 and 1, this is decay. Decay. It's going to be going down this time. So, go and plug some numbers in here. I'm going to plug in the same numbers I did before. 0, 1, 2, -1, -2. You can go plug these into a graphing calculator or utility, a TI calculator, Casio, whichever one you prefer, or even just use Desmos online or some of the other graphing utilities. And when you do, you'll see that the values you get are 2, 1, 1/2, 4, and 8. So to graph these, I'm at -2, 8, -1, 4, 0, 2, 1, 1, and 2, 1/2. So my graph goes down like this. It's going to be approaching it to the right. So my initial value is 2. My growth factor is 1/2. My growth or decay rate, remember it's 1, the absolute value of 1 minus the 1/2, which in this case would be 1/2. My domain is still the same, just like it was on the last one. It's all real numbers. We can write it in either format, and there's even more ways to write this, but going with this. The range still has the same restriction. It goes from 0 to infinity. Or we could say y is greater than 0. And the asymptote is the same as it was in the previous example. Y equals 0. As you start adding more pieces and parts to the equation, it will shift the equation around. But that'll come along in another video. I hope you've enjoyed and maybe have learned a few things. And don't forget to like and subscribe. Enjoy!